Hi students! In today's video, we're going to do some O-level questions on coordinate geometry. Right, let's start off by doing these questions. So on the diagram, you're given a kite A, B, C, D, in which the length of AB is equals to the length of AD, and the length of BC is equals to CD. Right, so we're given points A and point D lie on the x-axis, and point B lies on the y-axis. Right, so if you look at point B, points that lie on the y-axis will have x coordinate equals to 0, and points that lie on the x-axis will have the y coordinate equals to 0. Right. Okay, and you're given that h and k are not equal to each other. So for questions part A, you need to show that h plus k equals to 12. Alright. Okay, it's highlighted for you in blue and in yellow. Right, if you're given that AB is equals to AD and BC equals to CD, right, what we are saying that we can use the distance formula. So let's do a recap on the distance formula. Right, so let's do a recap on the distance formula. Right, so we can't use AB equals to AD simply because the point A is not given. So therefore, we have to use the second information, that is to find the length of BC equated to the length of CD. Right, so point C is given to be 6, 6. So let's go on to find the length of BC. Alright, so the length of BC would be, you can label point B as x1, y1, point C as x2, y2, and then you just substitute into your distance formula. So in this case here, your x2 will be 6. Let me erase this. Your x2 will be the value 6, so minus away 0, which is your x1, and you square it, plus, okay, y2, which is 6, minus away k, square it, equals to the distance CD. Okay, and then again do the correct substitution for your x2, x1, and y2, y1. Alright, so you have something square root equals to something square root. So when you square both sides, you simply remove the square root. Okay, so the next step is just to square both sides. Right, so when you square a square root, right, you simply remove the square root. And therefore the next steps will just simply expanding this. So 6 minus 0 is 6, so we square it, you get 36. And this, we should use the algebraic identity, which is bracket a minus b squared. That give you a squared minus 2ab plus b squared. Right. Then the next step is just to rearrange it. Alright, so k squared minus h squared, alright, you can factorize it. It's again one of the algebraic identity you've learned earlier on. You can factorize it as this algebraic identities you have learned earlier on, which is a squared minus b squared. That gives you a minus b brackets times a plus b, right? So therefore, your k squared minus h squared can be factorized it to be k plus h times k minus h. And this, that's a common factor 12, where you can just factorize it. Now you're given that k is not equals to h. K is not equals to h. So therefore, you can just divide both sides by k minus h. If k is equals to h, then you cannot do it. Because if k is equals to h, then you're dividing it by 0 on both sides. Right, which is something divided by 0 is undefined. So you can't do it. But because k is not equals to h, you can just divide both sides by k minus h. So that will give you h plus k equals to 12, and that's exactly what we're required to show in part A. So just do a recap on this part A. So in part A, basically, we're just using the distance formula. All right, the distance formula to find the equations, and then the next thing is to apply your algebraic identities. A squared minus b squared equals to a minus b times a plus b to factorize your k squared minus h squared, and deriving your final answer, which is h plus k equals to 12. Right, so let's look at part B. Part B, you asked to find the coordinates of point A. All right, so we're given that h is equals to 4, so we can just simply substitute h equals to 4 into your h plus k equals to 12. And you end up getting k equals to 8. So with h equals to 4 and k equals to 8, you will be able to know the coordinates for point B and point D. So in this case here, we can actually go on to use the first information given to us. Yes, which we can use the information AB equals to AD, and we shall call point A, we shall let the x coordinate of point A be x. And because point A lies on the x-axis, so the y coordinate is 0. Right. Yes. So we're going to use the distance formula again. So we're going to find the distance for AB. Right. And then find the distance for AD. Right. Square both sides to remove the square root. Okay. And then simplify it. Right, so you get x equals to negative 6. And it makes sense, your answer makes sense, because if you look at the diagram, point A lies on the left side of the coordinate on the axis, right? So the x coordinate of point A should be a negative value, right? So your answer makes sense. So therefore, point A is negative 6, 0. All right, so we're done with part B. So part C is relatively easy because we have already know all the 4 points, 5 points, sorry, A, D, C, B, sorry, 4 points, A, D, C, B, and we can just go ahead and use the shoelace method. It's easier. Of course, there are other methods of doing it, but I think using the shoelace method is easier. So remember, shoelace method, the formula, there must be a half there with 2 vertical lines, and then you must take the direction in an anti-clockwise direction. That's very, very important. Okay, take note of it. Take it in the anti-clockwise direction. And when you arrange the coordinates, you arrange the x coordinate first, followed by the y coordinates in the vertical direction, vertical format. Okay, so I start off with point A, which is negative 6, 0. Go on to point D, which is 4, 0. Point C, 6, 6. Point B, 0, 8. And back to your point A, which is negative 6, 0. All right. Okay, so the first bracket is, you just take a negative 6 times 0 plus 4 times 6 plus 6 times 8 plus 0 times 0. That gives you 72. Minus away the other direction, which is 0 times 4 plus 0 times 6 plus 6 times 0 plus 8 times negative 6. That gives you negative 48. And from there, you can just simply use a calculator to work out the value to be 60 units square. All right, so we complete doing question 1. Let's move on to question 2. Right, for question 2, all right, it is not difficult. The concepts involved are not difficult, very straightforward. But the difficult part is the algebraic manipulation. All right, because you need to solve simultaneous equations. Right, so you will have to work on your proficiency in your algebraic manipulation. All right, so let's look at the question. So you're given the triangle ABC, it's a right angle triangle. All right, angle ABC is 90 degrees. You're given the equations of the line BC. Right, you're given a point A, which is negative 2, 6, and point C lies on the x-axis. All right, so again, the y coordinates of point C will be 0. Okay, you asked to find the coordinates of point B. Right. So we have to make use of what we're given. Okay, so the things that we're given is basically the equations of BC. Right, so that is the information given to you. So we make use of that. We're going to rewrite it into the format y equals to mx plus c to find the gradient of BC. All right, maybe you want to think about why is it that we want to find the gradients of BC. How is finding the gradients of BC help us to solve this question? Think about it. Okay, so let's rewrite it, and then you would have gradient of BC to be negative 3 over 2. All right, I'd like you to look at the diagram again and see how it's the line BC connected to the line AB. Yes, AB is perpendicular to BC, and therefore, what is the concepts that involve gradients of two perpendicular lines? Yes, when two lines are perpendicular to each other, wait, I should not be using yellow. I think this computer, this laptop sometimes is a bit cuckoo. They just change the color for you without your consent. All right, so when two lines are perpendicular to each other, the gradient of M1 is negative 1 divided by gradient of M2, or the gradient of M2 is negative 1 divided by the gradient of M1. So in this case here, I'm able to find the gradients of AB, which is just negative 1 divided by the gradient of BC. Okay, and that gives you 2/3. And the next question is probably you want to ask yourself is that why do I want to find the gradients of AB? Yes, I'm interested to find the equations of AB. And why do I want to find the equations of AB? Okay, let's go on to find the equations of AB first before we answer the questions. Right, so I'm going to use the formula y minus y1 equals to m bracket x minus x1 to find the equations of AB. This is slightly shorter than having to find the y-intercept. And then my x1 and y1 is just one point that lies on the line AB. And the only point that lies on the line AB, given the value, it's point A. So we have to use negative 2,6. Substitute into this formula, and you will be able to find the equations of AB, right, to be 2/3 x, y equals to 2/3 x plus 22 over 3. So let's go back to the questions. Why is it I want to find the equations of AB? Yes, because if you look at the diagram, you will realize that B is actually the intersection point of the line AB and BC. Yep. All right, so I'm going to call the equations, or let the equations of BC be 1, the equations of AB be 2. Yes, okay, as what I've explained earlier on, B is the intersection point of the line AB and BC. Therefore, I'm going to solve these two equations simultaneously, right, to find the coordinates for point B. All right, so this is the part when I say that you need a little bit of algebraic skills. Okay, so what I've done is I'm just going to group all your term involving x on the left hand side, and all other terms go to the right hand side. Okay, so basically you can just factorize your x out here. To get negative 3 over 2 plus, negative 2/3. And you can just use a calculator to work that out. And that comes out to be negative 13 over 6x. And likewise, you can just use a calculator to work this out to get negative 91 over 6. So therefore, x is just, and then you have negative on both sides, just multiply by negative 1 on both sides. That will give you 13 over 6x equals to 91 over 6. So x is 91 over 6 divided by 13 over 6 flip. the fractions, or you can just simply use a calculator. You will get x equals to 7. So the x coordinate of point B is 7, and we're not done yet. You have to substitute into equation 1 or 2 to find the y coordinates. So in this case here, I actually substitute into equation 1. Right, so the y coordinate is 12. So therefore your point B is 7, 12. Okay. All right, let's look at part 2. Part 2 is relatively easy because you just need to apply the formula to find midpoint of a line segment. In this case here, you're given that M is the midpoint of AC, of the line segment AC. Okay, and then your ABCD is a rectangle, so you need to find the fourth vertex. Okay, find the fourth vertex, which is point D. All right, so before we can actually go on to find M, you need to know the coordinates of point C. Right, and that is not difficult because we already know the equations of BC. And since we know that C lies on the x-axis, the y-coordinate is 0. Yes, so we can call point C, we can let the x-coordinate be A, y-coordinate be 0. And we can substitute y equals to 0 into the equations of BC, which is given to be 2y plus 3x equals to 45. And from there, you can find x to be 15. Right, so we can find the point C to be 15, 0. Right, and then as usual, we label the point A as x1, y1, point C as x2, y2. Oh, I did it the other way around, sorry. I label point C as x1, y1, point A as x2, y2. Then we can just use the formula to find the midpoint of a line segment, which is just basically x1 plus x2 divided by 2, y1 plus y2 divided by 2. So that gives you 6.5 and 3. All right, so how do we find the point D, which is the fourth vertex of your rectangle? Correct. So if you were to recall the earlier concepts we have learned, there's certain quadrilateral, okay, that's very unique in the sense that the midpoint of each diagonal is the same. So one of them is rectangle, the other one is a rhombus, third one is a square, fourth one is a parallelogram. So all these 4 quadrilaterals have this unique property. Okay. So what we're going to do is going to find the midpoint of your diagonal AC. Okay, and also midpoint of your diagonal BD. Right. And since, yes, I explained earlier to you, because ABC is a rectangle, the midpoint of the diagonal BD will be equal to the midpoint of diagonal AC. So therefore, your 7 plus 8 over 2, these two values will be the same. And that two values will be the same also. Right, so from there you can find A to be right. Let's look at the next questions. I must say that of all the questions that we've done so far, we are left with 2 more questions. This is the second last questions, and I must say that this second last questions, it's a very challenging question, very challenging, especially for part I. And the good thing is that, yeah, the sector understands that some students may have trouble finding part I. And if you have trouble finding part I, you can't actually proceed to part 2 and part 3. Therefore, for part I, okay, the sector helps by showing that P is equals to 5. So if you can't really show that P equals to 5, you can just basically use the value for P equals to 5, use it to solve part 2 and part 3. Okay, so if you cannot do part I, don't just throw the questions away. You basically can just use the value given in part I and then use it to solve part 2 and 3. Alright, so part I is rather challenging. Okay, why do I say that? So the first, you can still earn a few points. 2 points. You can still earn 2 points by finding part I. So it's not totally gloom and doom. Okay, as in asked to find the gradients of the lines AB, which is relatively easy. Just y2 minus y1 over x2 minus x1. So that gives you p minus 1 over 0 minus bracket 0, 2 gives you p minus 1 over 2. And you can also go on to find the gradients of BC, which is p minus 3 over 0 minus 1. Okay, and that gives you p minus 3 divided by negative 1. And I just simply put the negative 1 at the numerator. Alright, and then just multiply, open up the brackets to get negative 2 plus 3. Okay, so here comes the tricky part. Alright, so the tricky part is that usually whatever they ask you to find, it's easier to just continue with the information you found. Alright, so you're given the angle ABO is equals to angle CBO. So you're given this information. So what I've done here is I'm going to let the angle ABO equals to angle CBO, and I'm going to call it theta. So if you look at the diagram, okay, I have the theta there. The next thing is I'm going to extend the line BA to touch the x-axis. Also, yes, I'm going to call the angle alpha, because what I'm going to use is the concept that we have learned earlier on also, that the gradient of a line segment is equals to tangent theta, and theta is basically the angle that makes with the x-axis in a anti-clockwise direction. Okay, measure in anti-clockwise direction. So therefore, what we are saying is that the gradient of AB is just tangent alpha. Alright, and I'm going to extend the line BC longer so that it touch the x-axis. And you see that the angle is also alpha. And therefore, the obtuse angle is 180 minus alpha. So the gradient of BC, the gradient of the line BC will be tangent bracket 180 minus alpha. Because remember that your angle must be measured in a anti-clockwise direction. Right, so the gradient, okay, the gradient for the line BC is not alpha. It's this obtuse angle here. Okay, the angle must be measured from the x-axis in the anti-clockwise direction. So this particular angle, tangent of the angle will give you the gradient BC. Alright, and we learned something, we learned trigonometric ratio of obtuse angle, if you were to recall. That's why I say this question is challenging, because it involves a few concepts. If you were to recall, we learned trigonometric ratio of obtuse angle. Obtuse angle, sine theta is sine 180 minus theta. Cosine theta is negative cosine 180 minus theta. And tangent theta is negative tangent bracket 180 minus theta. So therefore, your tangent bracket 180 minus alpha basically is negative tangent alpha. Alright, so from there, what's the conclusion? Yes, therefore we conclude that the gradient of your line AB is equals to negative gradient of line BC. Okay, I think I need to erase this. Okay, so therefore the gradients of AB, we found it to be P minus 1 over 2 equals to the gradient of BC, which is negative P plus 3. And then you need to multiply this guy with a negative. Okay, because of this. So negative, negative become positive, that ends up to get P. This one here will end up to get P minus 3. Multiply by 2 on both sides. to get p minus 1 equals to 2p plus minus 6. All right, and then simplified it, you get p equals to 5, which is what you are asked to show in part 1. Right, let's look at part 2. So we've already shown that p equals to 5, so we can just substitute that into point B to get 0, 5. All right, you asked to find the coordinates of D. All right, so how are you going to go about finding the coordinates of D? Okay, so if you look at the diagram, all right, D is actually the intersection point of AD and DC, right? Yeah, so it's a 6 mark question, 6 marks questions. So basically what you need to do is to find the equations of AD, find the equations of CD, and solve these two equations simultaneously. All right, so this is what we're going to do. So we're going to let point D be x, y. And again, I must say that this is the part that is very challenging. Algebraic manipulation is very challenging. Okay, so yeah, you need to work on that if you're not strong in that algebraic manipulations. All right, so you're given gradients of AB to be not given. We can find gradients of AB to be 2, or you can just basically substitute P to be 5 into the part I. Part I, we already got the gradients of AB in terms of P, right? And then you can get 2. And therefore the gradients of AD, because the AB is perpendicular to AD, so the gradients of AD will be just basically -1 divided by the gradient of AB, which gives you -½ And from there you see that I use the gradient formula because I let your point D be x and y, right? So therefore if you use y1, use y2 minus y1 over x2 minus x1, okay, which I let here, what I've done is I let this be x2 y2, this guy here be x1 y1. You will have y minus 1. Oh, I do it the other way wrong. Oh, sickening. Never mind, let's relabel it. Okay, so that will be 1 minus y over -1 minus x. Okay, and these two gradients are the same. These two values are the same because they both refer to the gradients of AD. So you can just equate them. All right, and then multiply both sides by -2 minus x. All right, and -½ times -2 gives you 1. -½ times -x gives you +½ x. We're going to make y the subject here, and y is equal to -½ x. So we're just going to keep that. Okay, then the next thing is I need to find, because I need to find the equations of DC, right? So I need to know the gradients of DC, which again you just make use of y2 minus y1 over x2 minus x1. And since DC is parallel to AB, right? DC is parallel to AB, right? So the gradients of DC is 2 as well. And these two values, you can just equate them to form a second equation. Right. And you can just substitute equation 1 into 2. Which one is your equation 1? Your equation 1 is this guy here. So you just substitute equation 1 into 2. Right. And then do some manipulations. And you can find x to be -2/5. And you're not done yet. When x is equal to -2/5, you have to substitute into either equation 1 and 2 to find your y coordinates. Okay, that's how we find point D. Right, the last part is the easiest, the shoelace method. I really like shoelace method because you just need to be very careful and you just need to take the directions in the anti-clockwise direction and you're fine. And just remember the formula correctly. Okay, so the formula is a half there. A lot of students forgot to remember the formula correctly. Many of them forget there's a half here. Okay, and then arrange it in a anti-clockwise direction, very important. So what I've done here is I start off with point A as usual, go on to point D, point C, point B, then back to point A. And I always like to do it this way first, because I know the first bracket will come from this direction. First bracket will come from this direction. Okay, just take negative 2 times 1/5 plus negative 2/5 times 3 plus 1 times 5 plus 0 times 1 will give you 17/5. Minus the second bracket will come from the other direction. Okay, and then again just use your calculator and work out the values to be 6.8 units square. Alright, let's conclude the second last question. Right, let's come to the last questions. And I must say the last questions is really the most challenging questions in terms of algebraic manipulations. The concepts are not difficult, really. Just that to do part I, you will have to solve two simultaneous equations. And it's very tough. Okay, right. So let's look at the questions. You're given a parallelogram. Right. So for parallelogram, there are certain properties that you need to recap on. Right. What are the properties? Correct. We know that the distance AB is the same as distance DC. We know that the distance BC is the same as distance AD. And we know that the opposite sides are parallel to each other. Okay, let's look at the questions. The questions are you're given that point A, point B, point E, and the parameter of the parallelogram is 46 units. So how can I make use of this parameter? This is a question you need to ask yourself. And the next question you need to ask yourself is, what is the parameter of this parallelogram? How do you find the parameter of this parallelogram? Yes, is to take the length of AB plus BC plus CD plus DA. That gives you 46, right? So parameter refers to the length. So look at the diagram again and tell me which length, which line segment you can find. Yes, of course, the line segment AB. Because these are the only 2 points that you're given the x and y coordinate, right? So we're going to use the distance formula to find AB, right, which come out to be 13. And what we are saying here is if AB is 13, your DC is also 13, right? This is 13 units. DC is also 13 units, right? Then from there, I'm able to find the length AD, right? Which is just basically 46 minus 13 times 2 divided by 2, right? 46 minus 13 times 2, yeah, divide by 2 to give you, why divide by 2? Because whatever remaining, if you take 46 minus 13 times 2, whatever remaining is the total length for AD and BC. So you need to divide by 2 to find AD. Alright, so AD is 10 units. Okay, so what we're going to do is I'm going to let the x coordinate of D be x and y coordinates be y. Why I want to let it be x and not A? Right, so because basically I'm just need to, finally my answer must be in terms of x, because you need to show that the x coordinates of D satisfy 5x squared plus 6x equals to 11. So may as well just let the x coordinate of point D be x. Okay, and then the y coordinate be y. Okay, so how do we go on? So once we know the x coordinate of D is x and y coordinate is y, we can just go on to the distance formula, use the distance formula to find AD. Yeah, and see how complex it is. It's bracket x plus 5 to the power of 2 plus y squared. And that value is actually equals to 10. So we can simply do square both sides to remove the square root of your left hand side. Oh, I didn't continue from there. Okay, I'm just going to leave it there alone first. And what's the next thing I am doing? Oh, because the next thing is that I need to form another equations to solve simultaneously with AD, right? Right, because I have two unknowns here. I need to find x. and also the unknown y. So basically I need to have two equations. So from the diagram, we know that the gradient of dE, we're using this in case you have lost focus. We're going to use this one here, this line. So the gradients of dE is equals to the gradient of EB. Basically, your point D, E, B are collinear. They are collinear. So gradients of dE is equals to gradient of EB. And from there, you can come up with a second equation. Okay, that's the second equation. So I need to substitute this second equations into your first equations we found here. Okay, let's see how we continue. Yeah, so I'm just, as what I mentioned earlier on, I square both sides to remove the square root of the left side. All right, and then I will just expand your x plus 5 to the power of 2 gives you x squared plus 10x plus 25. And then I make y squared the subject. We're going to call it equation 2. Likewise, I'm going to go back to my earlier, the green working, where I found y equals to negative half x plus 17 over 2. Right? I'm going to square it to find y squared. Yeah, and I'm going to equate these two equations. This one is equation 1. Okay, so you can see that it's really a lot of algebra there. All right, you have to look at it very carefully, slowly, understand it, and then do some manipulations, and you will get 5x squared plus 6x equals to 11, which is exactly what you need to do in part I. Okay, what some students may do is may just go ahead and factorize this. Means that you actually make use of this information, factorize it to get the x coordinate, which is a wrong concept, because you need to show this equation. Okay, you have to show the equations. You can't basically just use it and work backwards. In part I, you have to basically work forward. Means you have to finally show that you have 5x squared plus 6x equals 11. That's why it's 7 points. Can you see that's why you're given 7 marks? So if your solutions are just 3 or 4 lines, then it's the wrong concept. Because for 7 marks questions, they can't possible just give you, 3, 4 lines. If you look at the answers we have, okay, there are many steps involved. We have to use distance formula, and then we have to use the algebraic identity to factorize it, a lot of algebra, then finally solve them simultaneously. Okay, that's how much you need to do to get the 7 marks. But supposing if you can't do part I, then how? It's all right. You can still make use of the answer for part I to do part 2. So how do we do it? Okay, so how do we do it? So using the answer from part I can just simply factorize it. All right. It's a quadratic equation. Factorize it, and you have two values that you get from the x coordinate. One is a negative, one is positive. Right. So the question says that why the diagram is necessary. Yes, because you have two answers there, right? You need to reject one of them. So if you base on the diagram, looking at the diagram, you can see that actually your point D lies on the positive side. That means your x coordinate of point D must be a positive value. So therefore, you reject the negative one. So therefore, x is equals to 1. Okay, as explained there. So when x is equals to 1, you can substitute into the earlier equations where we found earlier on part I, where we have found the equations of, I cannot remember, is that the equations of AD? Yeah. Find the equations of AD, substitute inside there to find your y coordinate. So therefore, your point D, it's 1, 8. So that's 3 marks. So part 3 is to find the coordinates of C. And I must say that there's rather quite a lot, a few steps to do part 3. I'm using the distance formula to find part C. Okay, because this is the parallelogram, right? So for parallelograms, the diagonals will cut in the same midpoint, right? So let point C be A comma B. So midpoint of BD, because you already found point D, right, which is 1, 8. Here, this is 1, 8. So we can just find the midpoint of BD to be 4, 13/2. Then go on to find the midpoint of AC, and then equate these two values. The midpoint will be the same. This will be equals to this, because the midpoint of both diagonals will be the same, because this is the parallelogram. A few other quadrilaterals that have this property will be rhombus, square, rectangle, and rhombus, square, rectangle. Yes, and parallelogram, 4 of them. Okay, the big fours. And then you just equate them, and you can find A to be 13, B to be 13. Therefore, the coordinates of point C is 13, 13. Alright, so that ends this video on solving some of these O-level questions on coordinate geometry. And I must say that the last two questions are really challenging. Alright. Okay. Alright. Happy studying.